Welcome to Spotlight on Climate. Today we have David Spence with us, and David has agreed to talk about hydrogen as an alternative fuel source. Welcome, David, to Spotlight on Climate.
Thank you, Talene, and hello to all the listeners out there in Sunnyside Radio Land.
That's great because we have a few listeners out there. So, David, okay, right off the bat, I'm going to ask you, what are you talking about? Hydrogen. Doesn't that constitute a worry?
Well, just the opposite, Talene. The hydrogen is a potential solution to our global warming and climate change crisis. And when I say potential, I mean that it's still in the developmental stage to be applied at scale. Just for some background, hydrogen is the lightest element of God's creation. It's the most abundant element in the universe. It constitutes 72% of the mass of our universe. And if you want to start counting, hydrogen accounts for 90% of the molecules in the universe. So hydrogen, even though we don't hear it or see it or feel it, is everywhere around us. Now, it's a minute part of our atmosphere. Our atmosphere is mostly, as everybody knows, mostly nitrogen, almost 80% nitrogen, 20% oxygen, and then a whole group of trace gases that are responsible for our global warming, including carbon dioxide. Hydrogen is only 0.5 parts per million, and that, just to put it in familiar terms, the carbon dioxide, which we all know is rising as a result of burning fossil fuels, carbon dioxide is 420 parts per million. So hydrogen in our atmosphere is a very, very rare gas, if you will. But there are ways to get hydrogen as a fuel, and I'll come to that in a minute, and as a energy storage mechanism. And that is the subject of our discussion today. How can we use hydrogen as a benefit in our global warming, our climate crisis? And I want to start by kind of debunking one of the myths about hydrogen, is that it's dangerous. And everybody has heard of the Hindenburg disaster in 1937, when dirigibles, or lighter-than-air vehicles, were being used in our world. There was the Hindenburg dirigible that made a cross-Atlantic journey. It was coming into Lakehurst, New Jersey, in a rainstorm, and the captain of the airship made a decision to dock the airship during an electrical storm. Now, for background, there was enough diesel fuel on board to go completely back across the Atlantic Ocean and return to home base in Berlin. But the captain of the airship made the decision to dock in a rainstorm. There was lightning strike, and electricity sparked a fire in the hydrogen, which was making the dirigible lighter than air. That hydrogen fire went straight up in the air and did not harm anyone. What caused the loss of 38 lives was the flammable exterior coating of the dirigible, the flammable drapes and carpets, and all that diesel fuel that was on board. So it was a ball of fire when all those things caught on fire. There were about 50 survivors, fortunately, but indeed 38 people lost their lives in that disaster. That spelled the end of lighter-than-air transport, and there are certainly people that are trying to revive that as a means of transporting people and goods on our planet. But getting back to the hydrogen potential, it can serve as a fuel for vehicles, and that's through the mechanism of a fuel cell electric vehicle. It can also serve as an energy storage mechanism similar to a battery or compressed air. A number of energy storage mechanisms are being investigated around the world to help even out renewable electricity.
Okay, so let me interrupt you there.
Sure.
You're talking about hydrogen as a fuel source in cars. And you said that the Hindenburg blew up because of the diesel on board and the flammable drape. Hydrogen didn't have anything to do with that. So is it any less or more combustible explosive than gasoline?
That's a great question, Talene, and to put it in perspective, if gasoline were to come on to today's economy and today's market as a new fuel, it probably would not be approved by the Environmental Protection Agency because it is flammable and explosive. We, as a people, have just learned to live with gasoline. When you go to fill your vehicle at a gas station, you're cautioned to put out your cigarette. You're cautioned not to have static electricity in the area. So we've learned to live with gasoline, and we can do the same with hydrogen. And just to be clear, yes, the hydrogen on the Hindenburg burned, but the flames, they're colorless, and they went straight up in the atmosphere. So the huge conflagration, if you will, very dramatic, the huge conflagration that killed people on that docking area for the Hindenburg were the combustible things that were on board, not the hydrogen that was making the dirigible lighter than air. And I've been involved with hydrogen as a potential fuel for a couple decades now, and what I've learned is that if you have a hydrogen fuel cell car or truck or forklift, and you're using it inside a building, you need to have a peaked ceiling, because if there is a leak, hydrogen being so much lighter than air, the hydrogen will immediately go to the highest point in your enclosed building. So a peaked roof with a passive or active exhaust system at the top of the peak is the way to keep your building safe. And the hydrogen fuel that's inside your fuel cell vehicle, be it a car or a truck or a forklift, is in a compressed gas cylinder, fiberglass. They're bulletproof. They're very safe. A fuel cell electric vehicle has an inertial shutoff, similar to an airbag, if you will. If you're in a crash, your airbag deploys based on the loss of momentum or loss of acceleration. The same thing happens with your fuel cell delivery system. It's an automatic shutoff that locks the hydrogen into that protective cylinder, and fuel cell vehicles are safe in a crash with this modern technology. One thing to keep in mind is that if you have 1 kilogram of hydrogen, 2.2 pounds in the English system. So 1 kilogram of hydrogen at atmospheric pressure would fill the entire mixing drum of a cement delivery truck. So 1 kilogram at atmospheric pressure occupies a huge volume. In a fuel cell vehicle, that hydrogen is transported in a high-pressure tank, either 200 up to 600 atmospheres pressure. So the fuel cell storage on a vehicle is larger, the volume required is larger than for diesel fuel or gasoline, but it's manageable. And it's certainly less than battery-powered electric vehicles. And that's important when you get into long-haul trucking. Hydrogen is clearly one of the favored fuels for the next generation of long-haul trucks. And that's because the trucking industry makes their money by hauling tons of cargo. And if you're having to have batteries, which themselves weigh tons, that cuts down on your cargo capacity. Hydrogen storage on board a long-haul truck is much more profitable. So you're seeing fuel cell-powered long-haul trucks on the road now where the fuel can be supplied. And California has been a leader in this. California for a decade has had what they call their hydrogen highway. And the main interstate going north to south in California has almost 100 fuel cell delivery stations where cars and trucks can fuel. So it's coming, and we'll see whether that's 10 or 20 years in the future for Arizona.
Now, you talked about profitability and, the idea of hydrogen. The first thing I think of is, it's terribly expensive. But having said that, I remember, I'm giving away my age here, you'll be able to identify with this. When the calculator first came out, it was huge. It was, a good 3 or 4 inches wide by 6 or 7 inches. I mean, it was like a piece of notebook paper. It was huge. And it cost $100. And now that calculator It's part of your watch. It's on my phone has a calculator on it. It's everywhere. It's ubiquitous. And so do you see that happening with hydrogen?
Sure, it's a good question, Talene, and yes, it's going to happen either quickly or slowly. The Biden administration, through the Jobs Act and the Infrastructure Act, got a lot of money that has been put into hydrogen development as a fuel and as an energy storage for our climate crisis. And the goal of the Biden administration has been to have hydrogen cost down to cost less than $1 for 1 kilogram within a decade. So that decade, I think, ends in 2030 or 2034, depending on how you calculate these things. So that's an aspirational goal. Right now, a kilogram of hydrogen will cost you around $6 to $8, and you can buy it in a pressurized cylinder from one of the gas companies. In places where hydrogen is available at the pump on a highway or in a warehouse, it's probably around $3 to $4 per kilogram. One of my favorite stories about hydrogen as a fuel is for its use in forklifts. And this is...
I'm sorry to interrupt, but you've said forklifts several times. I'm really anxious to hear this. What?
Well, forklifts that are operated in a warehouse or a distribution center, and everybody's seen how these forklifts can lift a heavy load up 30 feet. If you ever go to Sam's Club or Costco, you see all these pallets, a building supply store. Industry relies on forklifts to manage storage. And if you've got a forklift working in an enclosed warehouse, you don't want it to be running on gasoline or propane, because that puts carbon monoxide and carbon dioxide into your workspace. An electric forklift is great because it doesn't produce noxious fumes, but an electric forklift has downtime while you're recharging the batteries. And for a warehouse industry, downtime is affecting their bottom line in terms of cost. A hydrogen fuel cell forklift is an electric forklift powered by hydrogen. You can refuel that in the same length of time that it would take to refuel your car with gasoline or diesel. So downtime is minimized, and there is no air pollution, no CO2 or carbon monoxide coming off your fuel cell. So it's a perfect example, and they indeed are in widespread use in warehouses around the country now.
So I wonder, we're going back to the Hindenburg thing again. Has it been somebody's interpretation of the facts that has kept us from achieving this goal?
Well, I think we just have to recognize that society deals with risks all the time. And the terrible fires in Los Angeles that are occurring right now are in part a result of burning fossil fuels. It's also weather-related, with the Santa Ana winds giving 80 to 100 mile-an-hour gusts of wind, spreading the fire, extreme drought conditions. So everything in our society is complex. And as we recognize the reality of global warming and all of the side effects that come with that, we have to take all of our risks into account. And a good example of use of hydrogen to mitigate the global warming crisis is that hydrogen can be used to decarbonize several industries. Steel making.
Really?
Cement making, glass making, petrochemical productions. These are all heavily dependent on fossil fuels. And to reduce fossil fuel use, for example, in steel making, you have a blast furnace, and that blast furnace burns coke, which is a form of coal, and it puts off a lot of CO2. There are several industries, several companies around the world that are producing green steel, and they do this by using hydrogen, burning the hydrogen in a blast furnace to make the steel. So it's a direct hydrogen there is a direct replacement of the coke or coal. Aviation fuel. There are experimental aircraft now that are using hydrogen in place of jet fuel or kerosene. And cement. Right here in Flagstaff, we have a company, Block Light, that makes cement blocks, and they're using a new technology. It's not experimental. It's a proven technology to incorporate carbon dioxide into cement and it is permanently sequestered. So if you look at the potential, think of all the concrete that's used in highways and buildings in our country. If we can incorporate carbon dioxide into that cement and lock it away forever, that's a win-win situation. So Block Light is on the forefront of reducing our global warming crisis by sequestering carbon dioxide in cement.
How are they doing that?
Well, it's a little bit of carbon dioxide at a time. I have not visited their plant, but it's an exciting technology, and the same technology can be used for ready-mix cement delivered to a road construction or a building construction site. We just have to deploy the proven technology. The technology is proven. You just have to spray the concentrated carbon dioxide into the cement slurry as it's being circulated in that ready-mix truck, and once the cement hardens, your CO2 is locked away forever.
So how does a person on the street support this idea?
Well, I just joined the city council as a new city council member, and I'm looking forward in our city regulations and our city building code to the idea of requiring cement utilization, Portland cement utilization, to incorporate CO2. Individual citizens can look for opportunities to get a fuel cell electric vehicle. Now, don't go out and buy one right away because there's no easy way to get it refueled. But if we here in Flagstaff put in a hydrogen fueling station that distributes green hydrogen, then people in Flagstaff could purchase a fuel cell electric car, and they're on the market in places like California and Connecticut where the hydrogen fuel is currently available. And those fuel cell electric vehicles are at a price point comparable to a battery electric vehicle. So it's coming. People just need to be patient and wait for industry and government to come together to make hydrogen fuel available. It's the old chicken and the egg thing. Which came first, the chicken or the egg? Well, you're not going to have fuel cell electric cars and trucks until you have a fuel distribution system that makes their refueling possible. And here in Flagstaff, we've got I-40 going through the center of town, long-haul trucks that are going cross-country. If they're powered by a fuel cell electric system, they're going to need to refuel somewhere between Albuquerque and Bakersfield. Flagstaff might as well be that place.
Right?
Talene, let me quickly go over that term green hydrogen, because
I was just going to ask you about that.
Okay, well, you're on track. Currently, there's millions of pounds or kilograms of hydrogen delivered to chemical industries around the country. That is called gray or black hydrogen, because, and we use a color scheme to illustrate how hydrogen is not currently a solution, because what they're doing, they're taking natural gas and using a method called steam reformation to produce the hydrogen. So it's contributing to our global warming problem. Black or brown hydrogen is using coal to produce the hydrogen. There's newer ways to produce hydrogen. The green hydrogen is produced using renewable electricity from solar or wind, and using that electricity to power an electrolyzer, which takes water and turns it into hydrogen and oxygen. So there's a water consumption factor, but it consumes less water than producing gasoline or diesel for equivalent amount of energy. So electrolysis of water is one way, but it's expensive. There is a potential source of hydrogen called geologic hydrogen, and it's just coming into a better level of understanding by geologists, and there may be places around our world, particularly in America, where hydrogen is stored underground through natural processes. Certain kinds of rocks, when water hits those rocks and the rocks are hot from the magma of the earth, hydrogen is produced. And we just have to find where it is stored and to investigate whether it could be recovered in an economically favorable fashion. But the good news is, as we move away from gas and oil, there are a lot of well drilling companies that are going to be looking for places and things to drill for, and drilling for geologic hydrogen is a possibility. And there's one other thing that's quite experimental now. I call it yellow hydrogen, and that is you can take, and this is in the research stage, where they have a panel that looks much like a photovoltaic panel, and as the sunlight hits it, the sun's energy, the photons, convert water that's being trickled through the panel into oxygen and hydrogen. So if this technique can be proven and developed economically at scale, it bypasses electricity. It takes the sun's energy, hits a panel, converts water into hydrogen and oxygen. You can use the oxygen to breathe. Flavored oxygen at an oxygen bar is popular in some places in our country. And you can use the hydrogen to store it for intermittent use, and you can power a fuel cell electric vehicle. So there are lots of possibilities, and we just have to keep our eyes open for how this can help us solve the climate crisis.
Oh, well, thank you very much for saying the word "and." That gives us real hope and action that we can engage in to combat this crisis we're in. Dr. David Spence, a newly elected member of the Flagstaff City Council, has been our guest talking about hydrogen. And we thank you so much for joining us. Next week, I can't tell you who my guest is next week. I haven't heard from David yet, but the other David. But we'll be back with Spotlight on Climate next Friday again. And there's a rebroadcast of this show Thursday morning at 10:30. Tune in for that as well if you want to hear Dr. Spence's information again and what he said about it. Thanks for tuning in. Spotlight on Climate, and we'll see you next week.
Spotlight on Climate is brought to you by the Northern Arizona Climate Change Alliance in conjunction with 101.5 FM Radio Sunnyside. Our host is Talene Corlin. This broadcast is produced by David Bull. Stephen Summers serves as executive producer. For feedback to Spotlight on Climate, or to learn more about the Northern Arizona Climate Change Alliance, visit nazcca.org.